In this tutorial we will learn how to build up or to perform a simulation using AquaCrop. We click on Start and then we see this template that includes all the information that we need to perform the simulation. First of all, we choose a climate file. Here we click on Select. Of course, this is related to historical data, and here we have a whole list of different files with weather. We're gonna use Santa Ella 0008, and we go back to the main menu. Now we have to choose a crop. In crop we go to select create crop. In this case we're gonna be simulating a cotton crop, so we're gonna specify the starting date of 1st of April 2000. Now we select the crop file, and within all the files available we're gonna choose cotton crop, and we confirm the sowing date April the 1st 2000. Okay, now we go to the Irrigation tab. We're gonna select an irrigation file if it is an irrigation schedule, which means that we supply the dates and amounts of irrigation, but we can go and generate an irrigation schedule. The file name of the irrigation schedule is going to be called Cotton Irrigation. Okay, put here the description. It's gonna be sprinkler irrigation, and in the lower part we let the 100% of soil surface wetted. Here we have the time and depth criteria. The time criteria is to irrigate either on a fixed interval using allowable depletion as a fraction of the readily available water or water layer between buds. We're gonna use allowable depletion. We're gonna be irrigating with a depletion of 60 mm. The depth criteria will be to go back to field capacity, which means that after irrigation the soil water deficit will be 0. Also here we can select the irrigation water quality. Let's consider that we're going to irrigate with a very poor quality. EC of the irrigation water 4 decisium per meter. We click Assign, and here we say that the criteria for irrigating is going to be irrigating after day number 1, when the soil water depletion is 60 mm, and at that time we will apply to go to field capacity. Here we could put a positive value if we want to apply more irrigation, or a negative value if we want to apply less irrigation than that required to go back to field capacity. We click on Create, and we have already defined our irrigation for this simulation. We're gonna leave the Field tab unchecked. We go now to the soil profile, and we're going to select a soil profile. Let's consider that we're gonna use a sandy loam soil and let's see what are the soil characteristics. The description is: this is a deep, uniform, sandy loam soil profile. The characteristics of the soil horizons: here we have a single horizon very deep, 4 meters depth, which means that the soil will not be limiting root growth, with a permanent wilting point of 10%, fill capacity of 22, and saturation at 41. Total available water is going to be 120 millimeters per meter. The KSAT, the saturation hydraulic conductivity, is very high, 1200 millimeters per day. Okay. The soil surface characteristics include a curve number of 46. This is the default value. We could change this value. Is a soil classified in hydrologic group A, which is good infiltration conditions, and the parameter for readily evaporable water for calculating soil evaporation is 7 millimeters. We leave it at that. We check if there are restricted soil layers, and we have no restricted soil layers. For capillary rise, these are the parameters. We're not gonna stop at that. And now we go back to the main menu. So far we have chosen the climate, the crop, irrigation, soil profile. We're not gonna consider a groundwater table, and we check on the simulation period. This crop will be ending on September 21st at maturity. The simulation period is going to be linked to the growing cycle, which means that we will only simulate the water balance during that period. Down below we see that we have more weather data than that, so that's okay. Now we're going to check initial conditions. Let's create or take initial conditions. For instance, we can consider that a dry over wet soil. Let's see what's in there. Dry topsoil at 10% and wet subsoil at 30%. And here in initial soil water and salinity content, we see the values for the different layers of the soil. The blue line marks the water content of the different layers. We see that on top it's rather dry, and the water content increases with depth and then stays constant. The salinity profile, we consider that there are no salts in the soil, or the salt content is negligible. Okay, we see here more parameters related to the potential development of the crop. We go back to the main menu. So we have already defined the initial conditions. We click on project, and we're gonna create a project file. We're gonna create, this is a single run project. We're gonna simulate a single season, and then we have single simulation run, and we click on create project file. When we click on create project file, we have here the different parameters corresponding to this project. We click on create, and we click on description as cotton Santa Ella 2000 on sandy loam, and we're gonna call it COT, SE for Santa Ella, and 2000. We click on save, Okay, now we have everything we need. We are not adding field data because we have no observed data to add. Then we are set to go and run the simulation. We click on Run, and then we can start the simulation. Here we can tell it to advance to different moments of the simulation or directly to the end of the simulation, which is gonna be September 21st, 2000. Here we can select also the output of the outputs that we want to see in this window. For instance, we can check on the climate and water balance, and we click on Start. Okay, and now the simulation is completed. And we have several summaries here indicating, for instance, the CO2 concentration, what has been the cumulative values of growing degree days from sowing to maturity, the reference ETO 954 millimeters, rainfall 182, irrigation 755. The irrigation events have been created automatically by the program, have been performed on June the 5th, June 15th, June 24, July 3, July 12, July 20, and so on. The last irrigation is occurring on September 18. Look at this. It is interesting to see that one of the problems with AquaCrop is that it does not consider the need for drying down the soil at the end of the growing season. With this irrigation schedule, if we irrigate on September 18, we will probably have a lot of water in the soil when we end the season. We close that. Okay, here on the top right part we have a summary of stresses due to soil salinity, temperature, water stress for canopy expansion, stomatal closure, or senescence. We see only some slight stress affecting canopy expansion. We don't have effects of soil fertility. The production is dry yield of 4.6 tons per hectare and biomass produced 13.1 tons per hectare. This is also biomass. We can also see the outputs of the model as numerical values if we prefer that. Here we see we can select the type of output files, for instance, the crop development, the profile or the total soil water content in the root zone. We can choose between soil water content or soil salinity. We can see values related to the soil water balance, of climate input parameters, those that are used by the model, or for the different compartments we can check on the water content or the soil salinity. For instance, let's see, we can go and see the values the soil water balance we have already commented, etc. If we want, we can also, when we try to go to the main menu, we have the option of saving output on disk. This means that all the files that have been generated during the simulation now can be saved in the disk. Let's say yes, and the output files that are generated have all an extension OUT. and the name is the first part of the file name, code SE2000, and CLIM is for climate input data, crop is for crop development and production, WABAL goes for soil water balance, PROF is for profiles of soil water content, SALT goes for the profile and root zone salt content of the different layers, comp WC for soil water content in the different compartments, or soil salinity in the different compartments is comp EC, and the net irrigation requirements are stored in iNet. We go and click OK, and the files are generated. Now we can exit the program, click on yes, and then in the same folder where we have AquaCrop, we can go to Outputs, and here we have all these files, all the files that have been generated by the model. We can import these files using, for instance, Excel. Let's see. We go and open, and then we go to the AquaCrop folder, Outputs. We click here all types of files, and these are the files generated by the simulation. For instance, let's consider that we want to check on the crop. We double click and then we select delimiters using space. We click on Final, and here we have a table that includes the day, the month, the year, days after planting, crop stage, cumulative growing degree days, the depth of the root system, etc. For instance, here in the end we have the total biomass of the crop until the end. We can have a look at that. Okay, this is the biomass, and we have the possibility of analyzing all the variables related to the crop or to the water balance.